Hey guys, this is Coach Lowe and this is Contextual Geometry, and we will be talking about Chapter 9, Ratios and Proportions. Alright, so we are in 9.1 and we are going to talk about using ratios and proportions. So in your notebook, you need to put ratios and proportions. And then you will need to go ahead and begin this next section. So let's just go ahead and, oh, by the way, you need to go back to your table of contents, right, and put the page number where you started this chapter 9 business on ratios and proportions. All right, so using ratios and proportions is 9.1. All right, so let's first define what a ratio is. A ratio is a comparison of two numbers by division. So a lot of times you'll see it written like A over B, like comparing the number of boys in a class to the number of girls in a class. So 4 boys to 11 girls, or a 4 to 11 ratio. You can also compare like this, 4 to 11, and you heard me say that, A to B. I've also seen it written like this, and you probably have too. This is A to B, that's the ratio, or in our case, 4 to 11. But in all of these cases, B cannot be 0 because you have, you can write any of these as a fraction like this, and division by 0 is undefined, so we don't ever want that. All right, so we want where B is not equal to 0. Remember, that means not equal. All right, so we want our ratios in simplest form, so make sure that you reduce those fractions. All right, so we want to make sure that we reduce every time. All right, sometimes these can even be written as decimal numbers. They don't have to be written as a fraction. So be aware of that. And as we get into similar polygons, those are called, that's called the scale factor, and we definitely can see that as a fraction. All right, we also want to make sure they do some kind of tricky things sometimes. We want to make sure as we're comparing these numbers, if they give us units, that we stay in the same units. So let's say that they give us, we want to compare 24 inches to 3 feet. So first thing we want to check, since they gave us units, are we dealing with the same units? And no, we're not. So we have the option, we can change inches to feet or feet to inches. It doesn't matter, it will be the same thing, and I'll actually work it both ways. But we know that 24 inches is the same as 2 feet. So comparing 2 feet to 3 feet is a 2 to 3 ratio. Or comparing inches to inches, 3 times 12 is 36. So we could have 24 inches to 36 inches. And I'm going to go ahead and take those units off because we don't ever put our units on the ratios because they're exactly the same. So 24 to 36, but remember we said we want to reduce. So when we reduce, we're right back over here in a 2 to 3 ratio. All right, so when we talk about looking at proportions now that you know what a ratio is, when we deal with proportions, we're looking at two ratios that are equal to each other, or two equivalent ratios. So two ratios that are equal to each other. All right, so in our case, we could use these 2 is to 3 as 24 is to 36. Maybe that sounds like some of those English problems that you do, like apple is to applesauce as, you know, those kinds of things. And so, yes, this is very similar to that. The question is, when we're working with equivalent ratios, a lot of times they'll leave a variable in one of these 4 spots and we'll have to solve for it. So let's talk about how that works. We end up with 2 cross products when we work with proportions. And the cross products are these guys right here, and they have names, means and extremes. And here's what I do. I go back to writing them like this A to B. So 2 to 3 is equal to 24 to 36. And I want you to think about extremes like way out. So stretch your arms way out, extremes way out. As you stretch your arms out, we're going to mark the outside of these because you're stretching way out. Those are the extremes. You're extremely long when you stretch your arms way out. So those are called the extremes. See, I wrote extremely because I was thinking about that. So those are called the extremes. The inside or the middle is called the mean. So these are the means and extremes. All right, the means and extremes are equal to each other because look what happens when I cross multiply. When I cross multiply, I get the extremes. 2 times 36 equals, and then I cross multiply here, 3 times 24. So I have the extremes here and the means here multiplied together, and they will be equal to each other. So I multiply this out, I get 72. Multiply this out, I get 72. So the means and extremes are equal to each other, which makes it super handy if they give us 3 out of the 4 things, because then we can solve. All right, so let's actually look at that. By the way, underneath this, let's just go ahead and write A over B is equal to C over D. So that proportion, we can cross multiply and get AD is equal to BC. I said BC and I wrote it backwards, didn't I? It's really the same thing, we know, but. So extremes, means. So extremes and means here. All right, it also works the other way. If we have A times D equals B times C, we can write it as A over B equals C over D. So getting those extremes here and means here. All right, with numbers, here's what it looks like. 1 over 4 equals 4 over 16. That is so true, isn't it? That's the same as saying 4 times, I'll do it the other way. We'll go the AD route. That's the same as saying 1 times 16 is equal to 4 times 4. All right, so this piece is saying 1 times 16 is equal to 4 times 4 can be written as fractions. 1 is to 4, so extremes, as 4 is to 16, means. All right, so if you have questions about that, make sure you make a little note so that we can talk about it when you get back to class. At this point, I want you to put a star right underneath these notes that you're writing. All right, so as you've written out these A over B equals C over D and all that good stuff, if you need to pause the video, then go ahead and pause it. But I want you to put a star right underneath this last one. Just go ahead and stick a star there. All right, example number 2. Let's work this proportion. So 24 is to 30 as 6x plus 4 is to 35. Now, when we just have numbers like this, fraction here, we can go ahead and reduce this. It makes life a little bit easier on us. So if you would like to go ahead and reduce this guy, I think we could probably at least divide by 6 on the top and the bottom. So 24 divided by 6 is 4, 30 divided by 6 is 5. So now 4/5 equals 6x plus 4 over 35. All right, let's go ahead and solve this proportion. I will give you a caution here. Anytime you see an addition or subtraction sign in the numerator or the denominator, in the top or the bottom, go ahead and throw some parentheses around it so we don't make the mistake of forgetting to multiply through. So let's get our extremes first. So 4 times 35 is equal to, and then let's grab our means, 5 times 6x plus 4. All right, now we want to solve this equation. So let's do some cleanup. First, 35 times 4 is 140. And then on the other side, we've got to get rid of this parenthesis, so we'll multiply this guy through. 30x plus 20. Subtracting 20 from both sides, 120 equals 30x. And then dividing by 30 on both sides, we see that x is equal to 4. Now our check is put 4 back in and make sure that we get the same numbers. So 6 times 4 plus 4. So 6 times 4 is 24. 24 plus 4 is 28. That's a blob now. So 28 over 35 obviously is not the same as 24 over 30, but remember we reduced this and we got 4/5. So can we reduce this guy and get 4/5? So is there a number that goes into both 28 and 35? It is absolutely not 5. or an even number. So how about 7? So let's divide top and bottom by 7, and that would give us 28 divided by 7 is 4, and 35 divided by 7 is 5. So it does check. We have 4/5 on this side and 4/5 on this side, so we are good to go. All right, example number 3. The ratio of kids to adults at a school-wide party is 2.5 to 1. All right, so the ratio of kids, I don't know what that word is right there. I'm not sure really. The ratio of kids to adults is a 2.5 to 1 ratio. If there are 300 kids, how many adults are there? All right, so we can set up proportions to solve this. Ratios, and then let's set it up as a proportion. So the ratio here of kids to adults, we have 2.5 to 1. Now, notice we did kids to adults. When we do that over here, we have to do the same thing. Actual number, 300 kids to how many adults? All right, so now we have our proportion set up, following the same steps that we did before. 2.5x equals 1 times 300. And then dividing both sides by 2.5, and you can definitely use a calculator. The calculator on your phone works great too. So x equals 120, and that would be adults. So we'll slide the unit on there. So if there are 300 kids, there will be 120 adults. All right, awesome. All right, last thing, geometric mean. The geometric mean between two positive numbers A and B is a positive number x that satisfies this proportion, so that works in this proportion. So if you're given two positive numbers, then the geometric mean between those two numbers is solving for x in this proportion. So check this out. Find the geometric mean between 3 and 8. So A is 3, B is 8. We'll plug it into this little guy right here. 3 over x equals x over 8. So 3 times 8 is 24, and x times x is x squared. Now I have x squared equals 24. Remember, to get rid of this squared, we take the square root of both sides, because that will definitely cancel that out. We take the square root here, and it's plus or minus. So x is positive or negative square root of 24. We're going to leave it like that for just a second. Remember that I said it's a positive number x, so that means what spits out here has to be positive. So I'm going to chunk the negative. X is a square root of 24. Now, there's probably a perfect square in here. So I see that this can be, 24 can be broken down into 2 times 2 times 3 times 2. Because there are two of these, or because the square root of 4 is 2, I can take a 2 out. So I'm going to take that out since there's a pair. These guys have to stay in because there's only one of each of them, and 3 times 2 is 6. So 2 times the square root of 6 is my answer, or the square root of 24 for the geometric mean. Now, if I'm always going to put numbers in here for these guys, is there a shortcut? Is there a shortcut? So we'll talk about that tomorrow. Shortcut question for you. All right, now I want you to go back to where you put the star on your paper, and I want you to circle it. All right, and then I will check it tomorrow when you bring me your notes. Expect to have a couple of problems for a little quiz when you walk in. This is Coach Lowe, and I'm out.